Section 7.5, Systems of Inequalities. So an equations in ax plus by equals c are straight lines when graphed. If we change the equal sign to an inequality, we obtain a linear inequality in two variables. A solution of an inequality in two variables is an ordered pair of real numbers with the following properties, which we'll discuss later. The graph of an inequality in two variables is a set of all points whose coordinates satisfy the inequality, and a solution is a set of all points on one side of a line which satisfy the inequality. So here are some steps for graphing linear inequalities. The first thing we're going to do is replace the inequality sign with an equal sign. If you have a less than or greater than equal to, less than or equal to or greater than or equal to sign, then we draw a solid line. If we have less than or greater than, we are going to draw a dotted line. Then we're going to choose a test point on either side of the line and test it. If a true statement occurs, then we're going to shade that side where the test point is located. If a false statement, then shade the opposite side of the test point. For example, graph 4x minus 2y greater than or equal to 8. So you can use any method that we've learned so far. I'm going to go ahead and use the x-intercept and the y-intercept. So here's my equation. So our first step is to change the inequality sign to an equal sign. And then I'm going to use the y-intercept. So remember, the y-intercept is whenever x is equal to 0, and then we solve for y. So y is equal to -4, so my y-intercept is at 0, -4. And then I'm going to find the x-intercept. And for the x-intercept, we let y equal to 0. So in this case, my x-intercept is 2 whenever y is 0. So now that I have my two lines or my 2 points, remember for a line, that's all we need is at least 2 points to graph the line. So I can plot my points, 0, -4, and 2, 0. And then we need to decide if we draw a dotted line or a shaded or a solid line. Since we have greater than or equal to, then this is going to be a solid line. Okay, so that takes care of step number 1. Then we need to choose a test point. The test point cannot be part of the line. So I'm going to choose a test point. The easiest test point, if it's available, is 0, 0. And here's 0, 0. So it is available because it's not part of the line. So when x is 0 and y is 0, we get 0 is greater than or equal to 8. Well, 0 is not greater than 8. So here's our test point. Since it gives me a false statement, then I'm going to shade on the opposite side. So what this means is that any point you choose on this side of the line is going to satisfy this inequality. Okay, let's try example 2. So here, notice that it's a greater than sign, so we're going to use a dotted line. And so my first step is to make this into an equal sign. And I'm going to go ahead and find the x-intercept by letting y equal 0, multiply by 4 on both sides. So we get 0, 0 for our x-intercept. If I use the y-intercept, then notice we also get 0, 0. So we do need 2 points. So far we only have 1. So there's 2 options. We can use the idea, the graphing using the slope and the y-intercept. So in this example, our slope is 3/4, so we can use that as our rise and this as our run. So my x-intercept and y-intercept at 0, 0. And then from this point, I'm going to go up 3. And I'm going to go across 4 for the slope. And then I have a dotted line. And I need a test point. However, my 0, 0 test point is not available. So I need to pick something else. So I'm going to choose 0, 1. So here, y is 1 is greater than 3/4 times 0. And so 1 is greater than 0. That is a true statement. So my 0, 1 point is right here. And it is true. So I'm going to shade on top. Okay, so let's go to the next page. Example 3. So first we can fill these out. If y is greater than mx plus b, shade the half plane above the line. If y is less than mx plus b, shade below the line. If x is greater than 8, we're going to shade half the plane to the right of x equals a. And if it's less than a, we're going to shade to the left. If y is greater than b, then we're going to shade above. And if y is less than b, we're going to shade below. So these are just some ways that we can graph. Or if you forget these statements, then we just simply go back to doing what we were doing in the first 2 examples. So for example here, y is greater than 1 would be this situation, which means that we're going to shade above the line. Okay, so here we get y is equal to 1. Well, this is a horizontal line, and it is going to be a dotted line. Again, if you're more comfortable, you can choose a test point. So I'm going to pick a test point here of 0, 0. 0 is greater than 1. This is a false statement. So my test point is here, and it's false. That means we're going to shade above. And notice that in this statement up here, it did tell us to shade above. Okay, the next one. X is equal to -2. It is going to be solid since I have the equal sign. And according to our statements up here, we're going to shade to the left. But we can also pick a test point to double check. Zero is less than or equal to -2. That's false. So here's my test point and it's false. So we're going to shade to the left. The next example is an inequality of a nonlinear. It's a nonlinear inequality. So we know that this is a circle. So if we want to graph this, the center of the circle, remember our general form of a circle is this here. So since I have no h and k in here, then our center is 0, 0. And then our radius is going to be r squared is equal to 16. So r is 4. Again, the center is HK, and then our radius is r. So if we graph this, we plot our center, which is here, and then we use the radius to go up 4, to the right 4, down 4, and left 4 from the center. It is a solid line, so my circle is going to be like this. And then we need to choose a test point. You can use 0, 0 in this case because it's not part of the actual line. So here I would get 0 is greater than or equal to 16. That's a false statement. So that means I shade on the opposite side. So it's going to be everything on the outside of the circle is my solution. Okay, so now we're going to be looking at a system of linear inequalities. So the first thing you want to do is graph the first line. And you can use any method. So I'm going to go ahead and use the x-intercept. That means that x will be 6. And then I'm going to use the y-intercept. That means x is 0. So here y would give me a -2. So that's for my first line. Then I'm going to go ahead and plot this line. So we have 6, 0, and 0, -2. It is a dotted line. And we need to do a test point. I can use 0, 0. So this would be 0 is less than 6. And that's a true statement. So I'm going to shade on top. Okay. Then we want to graph the next equation. So I'm going to use my x-intercept. Then y equal to 0. So divide by 2. So x is -3. And then I'm going to use the y-intercept. If x is 0, then here we get y is equal to -2. Okay, so let's plot those points, -3 and 0, 0, -2. It is a solid line. And then we need a test point. So my test point will be 0, 0. So 0 is greater than -6. That's true. So I'm going to shade above the line. So your solution for this problem is where you have both intersections. So notice here I have the lines going this way and then the lines that are going this way. So all of this area here is where it has both lines. So this is going to be my solution. So let's look at the next example. We have x plus y is equal to, x plus y is equal to 2. So x-intercept, we let y equal 0. So x is 2. And then the y-intercept, we let x equal 0. So y is equal to 2. Okay, for example 6, we found the x-intercept and the y-intercept. And so just recap here. To find the x-intercept, we let y equal 0. To find the y-intercept, we let x equal 0. And then we found the x-intercept for this equation. And so we get plus or minus 2, and then the y-intercept is 0, negative 4. So we need to plot or graph these equations. So the first line or equation is a line, and our x-intercept here is at 2, 0. And then our y-intercept is at 0, 2. This is going to be a solid line. And then we need to choose a test point. So I'm going to use a test point of 0, 0 for this line. So if x is 0, y is 0, we get 0. 0 is less than or equal to 2. This is a true statement. So we're going to shade below the line. Then the next equation is a parabola with 2, 0 as a x-intercept and negative 2, 0 as a x-intercept and 0, negative 4 as our y-intercept. It is a solid line since we have the less than or equal to sign or greater than or equal to sign. We need a test point for y is greater than or equal to x squared minus 4. I can use 0, 0. So we get 0 is greater than or equal to negative 4. That's true. So we're going to shade inside of this parabola. So notice that where they have both types of line is going to be this area. And so this highlighted part is the solution to the system. Let's look at the next example. We have 2x plus 3y. I'm going to change my inequality to equal sign. If I find my y-intercept, I let x equal 0. So 3y is equal to 6. That means y is equal to 2. And if I find my x-intercept, I let y equal 0. Okay, so that's going to be our points for the first line, and then we can do the same for the second line. If x is 0, then we get 3y is equal to 0, 0, 0. Notice here if y is 0, we're going to end up with the same point. So we do need an additional number. So we can say let x equals to 1. So here we get 2 plus 3y equals to 0. Subtract the 2, divide by 3. So y is negative 2/3. So when x is 1, y is negative 2/3. You could have chosen any number for x. I just happened to choose number 1. So now we're ready to graph these lines. So the first one, it's at 0, 2, and 3, 0. They're both solid lines. We need a test point. I can use 0, 0 as a test point. 0 is greater than 6, that's false. So that means we're going to shade on top. Then the second line, we have 0, 0, and 1, and negative 2/3, so somewhere around here. It is a solid line. And we need a test point. In this case, the test point cannot be 0, 0 because we're already using it. So let's use this point of 0, negative 1. So here x is 0, y is negative 1. So negative 3 is less than 0 is true. So we're going to shade below. So notice that there's no place where the two shadings intersect. So that means that there's no solution to this system. The next example, we have x plus y is equal to 2. So if x is 0, then y is equal to 2. And if y is 0, then x is equal to 2. So we're going to graph this line. So 0, 2, and 2, 0. It is a solid line. And then we're going to use a test point of 0, 0. 0 is less than 2 is true. So we're going to shade below. The next equation is y greater than negative 3. So this is a horizontal line at y equals 3, negative 3. And it is a dotted line also. And the test point, we can use 0, 0. 0 is greater than negative 3. That's true. So that means we're going to shade on top. So far, this area is what they have common. But now we have this inequality. So here it produces two different inequalities. So one is x is less than or equal to negative 2. So that's just going to be a vertical line at x equals negative 2. And this is going to be a solid line. Test point 0, 0. So negative 2 is less than or equal to 0. That's a true statement. So we're going to shade to the right. I'm going to use circles as my shading so we can distinguish between all these different lines. So if you notice so far in here is what they have in common, this little triangle. And then the last inequality is x is less than 1. So I'm getting that from here. X is less than 1 and x was greater than negative 2. So this is x is equal to 1. And it is a dotted line. So test point 0, 0. 0 is less than 1. This is true. So that means we're going to shade to the left. And I'm going to make little wavy lines to represent that shading. So it's kind of hard to see here, but where they have in common is going to be this area here. Okay, so let me put this on decimals. That way it's easier to see. So we have x plus y is less than 2. So it shades that in red. Notice the dotted line. And then we have negative 2 is less than or equal to x less than 1. So notice the shading there. And then the last one is y is greater than negative 3. And so if we compare this, then you can see that this is a lot darker in this area because it has all 3 shadings. So my solution is this area right here, which is what I have in here. So that was section 7.5.